Welcome once again in the class of water resource engineering. So we are learning the spillways. So far we have learned what are the spillway, what is the necessity and location of the spillway. So in this lecture we are going to see various types of spillway. I am Mr. Sogule, Assistant Professor, Civil Engineering Department. Various types of spillways. So these are the various types of spillway. So first is free overfall or straight drop spillway. Second is ogee or overflow spillway. Third is side channel spillway. Fourth is chute or open channel or through spillway. Fifth is conduit or tunnel spillway. Sixth is droplet inlet or shaft or morning glory spillway. And seventh is the siphon spillway. So we'll see one by one in detail. So free overflow or straight drop spillway. So this type of spillway is a type of in which the control structure consists of low height, narrow crusted wear and less vertical. So this is the simplest type of spillway and may be constructed on the small bunds or on thin arch dams. So it is the low wear and simplest vertical type fall type of structure, as you can see in the figure. So this is the figure. The downstream face of the structure may be vertical or slightly inclined. The crust sometimes extended to form a overhanging lip, which keeps a small discharge away from the face of the overfall section. The water falls freely from the crust under the action of the gravity. Since vacuum gets created on the underside of portion of the falling jet, sufficient ventilation of the nappe is required in order to avoid pulsating or fluctuating effects of the jet. The next is overflow or ogee spillway. An overflow spillway is most commonly used spillway. It is improving upon the free overfall spillway and it is widely used with concrete masonry, arch and buttress dams. Such a spillway can be easily used on valley where the width of river is sufficient to provide the required crust length and the river bed can be protected from the scour at moderate cost. The profile of this spillway is made in accordance to the shape of the overnappe or of the free falling jet over a duly ventilated sharp crusted weir as shown in this figure. Here you can see even the gate also has been installed on this particular type of spillway. So this is the kind of shape of this nappe and this ogee has been designed as per the this shape of this lower nappe. So this overflowing water is guided smoothly over the crust and the profile of the spillway so that overflow water does not break contact with the spillway surface. As I am telling you, the shape of the lower nappe of free falling jet over a sharp crusted weir can be determined by the principle of projectile. It generally rises slightly as it originates from this crust. From this crust it originates and this generally rises slightly. Then over this sharp crusted weir and then falls to make a parabolic form. Now, if the space between sharp crusted weir and lower nappe is filled with the concrete or masonry, so the weir is so formed with a profile similar to a ogee, that is S-shaped curve in the section and hence called ogee spear or the ogee spillway. This lower nappe will then become a crust of the spillway since the lower nappe of the free falling jet will be different for different head over the crust of the sharp crusted weir. The profile of the ogee weir is generally confined to the lower nappe that would be obtained for the maximum head over the spillway. In this free overfall spillway, the water jet falls clearly away from the face of the spillway, and the gap between The jet and the face is kept ventilated. While in a Ogi spillway, the falling water glides over the curved surface of the spillway, and here no space between water and the crust of the spillway under normal design conditions. Normally, the upstream face of the spillway is kept vertical, and the crust shape confirms the lower nappe of a vertical sharp crusted weir under the maximum head. But if upstream face of the spillway is kept sloping, the crust shape should be also conformed to the lower nappe would be obtained for an inclined sharp crusted weir. So this is generally the Ogi spillway. Here you can see the side channel spillway. So as you can see, so this is the dam and this is the reservoir. The side channel has been provided from here, and the water has been allowed from here. So a side channel spillway is the one in which the flow after passing over a weir is carried away by a channel running essentially parallel to the crest. The side channel spillway is usually constructed in narrow canyons where sufficient space is not available for an overflow spillway. The side channel spillway is also best choice where the long overflow crust is desired in order to limit the surcharge head and the abutment are steep. Now open channel spillway. Now the open channel spillway or the through spillway. So it is provided in following situation, that is when it is not possible to provide overflow spillway, when the valley is narrow, where the separate site for spillway is not available. Generally, in this type of spillway is provided on earth or rockfill dam and is isolated from the main dam. So, as we know, mostly the Ogi spillway is mostly suitable for the concrete gravity dam, especially when the spillway is located within the dam body. So, in this case, that is earthen and rockfill dams. So, separate spillways generally constructed in the flank or the saddle away from the main valley. So sometimes even for the gravity dams also a separate spillway is required because of the narrowness of the main valley. In such circumstances, a separate spillway may be provided. So the through spillway is the simplest type of or the open spillway is simplest type of the spillway which can be easily provided independently and at low cost. It is lighter and adequate in any kind of foundation, hence provided easily on the earth and rock fill. This spillway is sometimes known as a waste weir. If it is constructed in a continuation to the dam at one end, it may be called as a flank weir. If it is constructed in a natural saddle in the bank of river separated from the main dam by high ridge, it is called as a saddle weir. So this spillway generally consists of the steeply sloping open channel placed along the dam abutment or through a flank or a saddle. It leads the water from the reservoir to the downstream channel below. The base of the channel is usually made of reinforced concrete slabs, generally 25 to 50 centimeter thick. A light reinforcement about 0.25% of the concrete area is provided at the top of the slab in the both direction. The this channel is sometimes of constant width and is usually narrowed for economy and then widened near the end to reduce the discharging velocity. Expansion joints are usually provided in the channel at intervals of the 10 meters on either direction. The expansion joint should be made of watertight so as to avoid any under seepage or in its troublesome effect. Under drains are also provided so as to drain the water which may seep through or through the bottom and the side walls. These under drains may be in the form of perforated steel pipes, clay tiles, or rock filled trenches. If the slope of this channel can conform to the available topography, the excavation shall be minimum. but the slope of this channel must be high enough and should at least able to maintain a supercritical flow to avoid unstable flow conditions. When the vertical curve is provided at a point where the channel slope changes, it must be gradual and designed so as to avoid any separation of the flow. So this is a particular thing in the case of this open channel spillway. So here you can see this channel has been provided at the end of the dam and water is flowing on this particular channel. Now the tunnel spillway. A tunnel spillway is the one which a closed tunnel is used to convey the discharge around the or near a dam. The control structure for this spillway may be in the form of an overflow crust, vertical or inclined orifice entrance, and a side channel crust. A tunnel is designed to flow partly full, and it is not allowed to flow full because of the siphonic action may develop due to negative pressure being developed in the tunnel. So this is basically nothing but the tunnel and which allows the water to flow. Now the shaft spillway. So in this shaft spillway, as you can see in the figure, so the water from the reservoir enter into the vertical shaft which conveys this water into the horizontal tunnel which finally discharge the water into the river downstream. Sometimes the vertical shaft may be excavated through the some natural rocky island and rocky spur exiting on the upstream side of the river near the dam. So as you can see here, this is the shaft has been prepared and through this the water is going into this particular shaft. So around this artificial island the shaft may be constructed. For the small heights the shafts may be constructed on entirely of metal or concrete or clay tiles, but for larger heights reinforced cement concrete may be used, and for smaller heights no special inlet design is necessary, but for the large projects the flared inlet called morning glory is often used. The horizontal tunnel or the conduit may be taken either through the body of the dam, as may be done in the case of concrete dams, and below the foundation in case of earthen dams. The divergent tunnel is constructed for the diversion of the river, sometimes may be planned and used for the shaft spillway. So basically what had happened when you are going to construct the dam, so you have to divert the river, and for that the divergent tunnel has been uh, prepared or the board in the particular that area. So that tunnel can be used for the as a horizontal conduit for this shaft spillway also. The chart spillway may be adopted when the possibility of the overflow spillway and the through spillway, that is open spillway, has been ruled out because of the non-availability of the space due to topography. The choice may be lie between the side channel spillway and the shaft spillway. If some suitable rocks, spurs, etc. available near the reservoir on the upstream side, naturally the shaft spillway may become economical and consequently the first choice. The discharge through shaft spillway does not increase as a as at a such high rate as it increases in weir type spills. Hence, in the unestimated high flood occur, the shaft spillway may not prove useful as a weir type spillway, such as overflow or open spillway. Hence, the shaft spillway design should be much more conservative than the other type of spillways. A gradual transition must be provided between the vertical shaft and the horizontal conduit in order to avoid the danger of cavitation. The hydraulic analysis of short spillway is difficult and their functioning is generally tested in the models. The entry of debris and other materials flowing in the reservoir must be prevented from the entering into the shaft. Otherwise, they will clog the shaft or the conduit, especially at the junction point. Properly designed and tested trash racks or floating booms may be provided for this purpose. Since the shaft spillway is surrounded by the water on all sides, it may be connected to a dam or the hillside by the bridge. So here you can see this is the shaft spillway. It is generally look like a funnel and it is also called as a glory hole spillway or this morning glory spillway. Now the siphon spillway. Siphon spillway may be constructed in the body of the concrete dam where space is not available for the overflow spillway. So it is essentially consists of the siphon pipe, one end of which is kept on the upstream side and in contact with the reservoir, while other end discharges the water on the downstream side. So the two typical types of installation of siphons types are generally done, that is tilted outlet type of siphon spillway or hooded type of the siphon spillway. So what are the disadvantages of this siphon spillway? The flow would result excessive vibration in the dam body, which may cause expansion problems in the joint. Then there is a possibility of the cavitation of the for negative pressure, which is affected by the head between the upstream and downstream water levels. The repair and maintenance of the siphon spillway is difficult and it has the limited capacity because it is a kind of pipe like structure. That's why it has a limited capacity. So here you can see the siphon pipe installed in the gravity dam, that is here. This is the air vent and this is the siphon pipe. So obviously it is a pipe structure and closed conduit. That's why it has the limited capacity. So it has this disadvantages. So the first is the tilted outlet type of a siphon spillway. That is this kind of siphon spillway. So it is constructed within a body of the dam. When a valley is very narrow and no space is available for constructing separate spillway, the siphon pipes can be installed within the dam body, as you can see in the figure, and an air vent is connected with the siphon pipe. The level of air vent may be kept normal pool level, while the entry point of the siphon pipe may be kept still lower so as to prevent the entry of debris etc. in the siphon. And the outlet of the siphon may be submerged so as to prevent the entry of air into the siphon from the downstream side. When the water in the reservoir is up to or below the normal pool level, so air enters into this pipe and the siphonic action cannot take place. When once the water level in the reservoir goes up the normal pool level, that is this level, then if the one siphon is filled with the water, that is primed, the water will start flowing through the siphon by siphonic action, and like so water flows, so it will create a pressure and it will flow from the this particular pipe, and the outflow will continue till the water level in the reservoir falls back to the normal pool level. So up to when air start to enter from this particular air vent, so obviously that flow will stop. So this is the particular is siphon pipe installed within the body of the gravity tank. Now the hooded types. The construction of the hooded type siphonage is more commonly adopted. In this case, the reinforced concrete hood is constructed over an ordinary overflow section of the gravity dam, and the inlet of the hood is kept submerged to prevent the entry of debris or ice, etc. A small deep priming hood is also kept above the main hood, and both the hoods are connected by a air vent. The inlet of the deep primer hood is kept normal at normal pool level, and again the same thing is there, like we have seen this in earlier case. So again action is the same, and even the results are also same. Only thing is this looks like a hood, that's why it is called as a hooded type siphon. Then the priming device, as we have seen, these things are called as a priming devices. When the outlet is cannot sealed by the tailwater, some other device called priming device is used to lead the automatic priming of the siphon when at a certain rise of water level at the crest. The maximum rise of the water is called as a priming depth. The priming is accomplished by the means of the step called as a joggle, which deflects the sheet of water striking against the lower end of the cover or hood, the sealing of the lower end from the atmosphere. Sometimes the additional baby siphon may be installed as a priming device, as you can see over here. This is the baby siphon. So things are like this. And when the water level reaches slightly above the crest, the baby siphon, which is the additional siphon, starts running full, and the sheet of water issuing from it is arranged to shoot across the lower end of the main siphon, and thus so as to seal it from the atmosphere. This is the volute type of this siphon spillway. It has been designed in India by the Ganesh Iyer, as you can see over here. These are the deprimers, and when this thing start running fulls or pulling the water, unless this air not going inside, so till then it will continue the flow of water. So this is a siphon type of spillways. So this is all for the today's lecture. Thank you.